Hello and welcome to R&D Mathematics. Today we are going to talk about absolute value inequalities. Now, how about this? X less than 3. What does this mean? What values of x can take? You know what, let me make it equal sign. In last video we learned how to solve something like this. So either this is going to be x equal you put 3 and x equal you put negative 3, right? Which makes sense because that is the distance from 0, because this guy is x minus 0 equals 3. If you want the geometric interpretation, so from 0 1 2 3 places right here, 1 2 3 places to the left right here. Now with this, think about this. Can x be 2? Yes, right. Can x be 1? Yes, right. Can x be 1.5? Yes, right. So there are infinitely many solutions. Anything, exactly like linear inequalities, anything that satisfies this inequality is a solution. So this guys actually is equivalent to x sitting between negative 3 and 3. So that is one way of remembering. So some textbooks suggest you this is same as, right? And then how about this? What if you had this? In this case, if you think carefully, now our earlier one here, negative 3 to, see, negative 3 to 3, all the values in between this region. Now this one, absolute value of x is greater than 3. Now for example, x can be 4, right? And x can be negative 4 as well. So we can see what's going on now. So everything outside of this interval, so the complement of that interval, so we get this. So either you can remember this form, so this will give you x, x less than negative 3 and x greater than positive 3. But when we were talking about linear inequalities, you saw this can be written as, if you look it carefully in one expression, x is, okay, this is this part, and this part, if I reverse the way I am writing, if I rewrite it, this little arrow head towards x, so okay, towards x. But you have to be very careful. This can be a common mistake, like again, in one of my previous videos I explained this, but let me explain this again. When a student see this, it's very natural to think, okay, x is going to sit between negative 3 and 3. No, it's not. Carefully look, okay, very carefully read your inequality. X is greater than 3, so this part, and let me use another color. From this, x is less than negative 3, so this part. Okay, with that being said, there is an easy way of solving absolute value equation. Now let me teach you that. 3x minus 2, let's say another example. What you need to do, you don't have to worry about all those things. What you need to do, just write down your expression without absolute value. But first of all, if your absolute value is complicated, first you have to isolate it. You know what, let me show you. What if instead of this, what if you had negative 7, sorry, negative 8 less than what? No, plus 8, sorry, negative 8 less than negative 1. In this case, what you need to do, first add 8, to both sides to isolate this, then you get this, right? Now after this, what you need to do, this is the important part. The term involving absolute value, the expression inside the absolute value bar, just write it without absolute value, and then the sign, then the absolute value sign as it appears in your equation, just put it like this, in left and right. And then the number, positive part in the right place, negative part in the left place. It will work. Now you can actually see why it works with comparing with our previous page, with this part and with this part, but it will work. Now what you need to do, simply, this is a linear equation, linear inequality. So minus 2 from all three parts, so you get minus 9 here, you get 3x here, you get 5 here. So x is, when you divide by 3, negative 3, and three here. Wait a minute. I think I made a simple mistake. See, here minus 2, so I have to add 2 to both sides. So add 2, here minus 2, so add 2, add 2. See, this is what happens when you sometimes try to do it in your mind. So here negative 5, here 3x, and here 9. So now when you divide by 3, yes, you can do it like this because 3 is a positive number, the absolute value does not change. So 3, negative 5 over 3. Now read this carefully. It may be helpful to draw a picture. So 3 and negative 4, where are those? Okay, they lie in your number line like this. And now yes, x is greater than the left number and less than the right number. So yes, in this case it looks like this. How about let's do another example. How about this? 1 minus 2x greater than 5. Now 1 minus 2x, 5 here, negative 5. That's the tip I gave you, that's the technique. Now what you need to do, okay, minus 1 from all three places. So negative 5 minus 1, minus 1, minus 1. So I get negative 2x in the middle, negative 6 and 4, right? Now I have to divide by negative 2. Now in this case I would write this again, because when you divide in by negative 2, see, as I told you in one of my previous videos, when you divide, write it again and look at the number. So the number we are dividing is negative, so the absolute value reverse. So we have x in the middle, and negative 6 divided by negative 2, that's 3, and negative 2. Now read this carefully. Draw a number line, look at those two numbers, negative 2 and 3. Negative 2 is much smaller than 3, so negative 2 lies to the left of 3. And then x is greater than 3, so that side. And x is less than negative 2, so this side. And in interval notation, this is negative infinity to negative 2 union, and then 3 to infinity. So that's one place you have to be very, very careful. And I think that's enough for absolute value equations. Let's see you in next video. Thank you.